Tahniah. Secara langsung ini dibawakan khas kepada anda oleh Akademi YouTuber Malaysia. Sebuah inisiatif e-didik Malaysia dan Kelab Guru Malaysia. Tumpukan perhatian anda. Secara langsung akan bermula sebentar lagi. Link sijil akan diberikan di hujung siaran ini. Pastikan diisi dalam tempoh yang ditetapkan. Terima kasih.
Hello, good evening everyone. How are you, dear students and viewers? I hope that all of you are in great health by God's grace. Welcome to IU Online Tuition. It's free and it will always be free for all of you, dear students. Now, those who are here, you can introduce yourself, okay, in the live chat. Let us know your name and your school, okay? I am Teacher Yenny, the moderator of the day. All right, now let me introduce you to all the lovely teachers here with us. Okay, we have Teacher Im. Okay, Teacher Im is from College Tingkatan 6 Tapa Perak. She's also the head of 6th form in IU team. And then we have Cikgu Fatia from SMP Serdang, Selangor. She'll be controlling the live broadcast for today. We also have Teacher Lau from SMK Tinggi Klang, Selangor. She is the observer for today's class. Well, we normally save the best for the last. The VIP for today is Teacher Tang. Okay, Teacher Tang is from College Matriculation Selangor. She has been teaching for 8 years. Today, she will be teaching you the phase diagram. All right. As usual, I have to give you some gentle reminders. All right, before we begin, remember to use the chat section wisely. Okay, be courteous when you ask questions. Please give positive comments, all right, and be kind to each other. Remember to turn on your camera and microphone when you manage to enter the studio broadcast sometime later. And the last one, link for the cert will be given in the end of the session. And then you will be given 30 minutes to fill in the form. All right. In order to get the form, remember you need to have e-didik account. So make sure you have e-didik account. Okay. Well, without further ado, let's have Teacher Tang. Let's welcome Teacher Tang. Okay. Let's put your hands together for her. Teacher Tang, you may have the stage now.
Okay. Hi, students. So I'm Teacher Tan. I'm a teacher in College Matriculation Selangor, and I have 8 years of experience teaching chemistry. Before I start with the class today, I would like to introduce all the teammates first in the pre-U team. So first, we have the mathematics group. So mathematics group, we have Teacher Ying, Teacher Aileen, and Cikgu Zana. So mathematics group is led by Teacher Im. And then we have the biology pre-U team. So Cikgu Faiza, Cikgu Fatia, and also Cikgu Naini. And the biology pre-U team is led by Cikgu Faiza. And also the pre-U accounts team. So we have Madam Fizi, Cikgu Yati, and the account team is led by Madam Fizi. And for the chemistry team, we have Cikgu Shannon, Teacher Vivi Lau, okay, Cikgu Mawar, and me, Teacher Tan. Okay, and the pre-U chemistry group is led by Cikgu Shannon. And for the pre-U MURID and English matriculations group, we have our moderator, Teacher Yenny, led by Teacher Aisha. Okay, so now we come to the topic for tonight. So tonight I'm going to revise phase diagram with you. Okay, so in phase diagram, so tonight we are going to revise the 2 phase diagram that cover in the SK015 matriculations chemistry. So the first one is the phase diagram of carbon dioxide, and the second one is the phase diagram of water. So first we shall revise how to draw the phase diagram for carbon dioxide. So to draw phase diagram, there are 5 items you must remember. First is to draw the axis. So for phase diagram, always have the axis pressure versus temperature. Usually the pressure will be given in atm and the temperature in degrees Celsius. Okay, so the first item you need to have is the axis. And then the second thing is to plot the triple point. So plot the triple point. So triple point usually will be given. The triple point temperature and pressure usually will be given. So you just need to plot into the diagram. And the third thing is to plot the critical point. So again, critical point also will be given. So the third thing you need to do is to plot critical point into the phase diagram. And then after that, you can draw the sublimation curve, the melting curve, and also the vapor pressure curve. And then the last thing is you need to label which region represents solid and which region represent liquid and where is the gas. Okay, and then sometimes the questions will ask you to label supercritical fluid region. So where is the supercritical fluid region? So supercritical fluid region refer to the region or boundary where the temperature and the pressure is higher than the critical point temperature and pressure. So where is the region? So this is the region for supercritical fluid. Okay, so again, in order to draw or sketch the phase diagram, there are 5 items you must have. So first, axis. Second, label the triple point. Third, critical point. And fourth, you need to draw the sublimation curve, melting curve, and also the vapor pressure curve. And the fifth thing is to label which region for solid, which region for liquid, and which region for gas. And then now we move on to look at the phase diagram of water. So for water, also the same thing. If you want to sketch the phase diagram for water, also must include the 5 items. First, the axis, pressure versus temperature. Second, label the triple point. Okay, again, triple point always will be given. You just need to label where is your triple point. Third, label the critical point. Fourth, you need to draw the line for sublimation's curve, melting curve, and also the vapor pressure curve. Okay, and then the last thing is to label where is the solid, liquid, and the gas region. So for phase diagram of water, one more thing you need to take note is the melting curve. The melting curve. So the typical phase diagram will have positive slope for the melting curve, means that you draw it to the right. But for water, the melting curve is having the negative slope. Okay, will have the negative slope, means that you draw it to the left. Draw it to the left. Okay, we will discuss later on why the phase diagram of water having the melting curve slope to the left. Okay, having the negative slope. Okay, so pointing to the left. So again, if they ask you to label supercritical fluid region, must remember supercritical fluid region refer to the region where the temperature and the pressure is higher than the critical point temperature and pressure. So that is your supercritical fluid region. So now we can move on to look at the anomalous behavior of water. So this anomalous behavior of water causes the water to have the negative slope for the melting curve. Okay, so the typical phase diagram would be like the phase diagram of carbon dioxide, where the melting curve is having the positive slope. For water, it is atypical phase diagram. Okay, so means that the phase diagram is unusual. Okay, so the unusual, where is the unusual part? Is the melting curve. So for water, the melting curve is having the negative slope, means that pointing to the left. So why? So before we explain about the why the water having the melting curve, negative slope, we shall look at the phase diagram of carbon dioxide first. Okay, so why the melting curve for carbon dioxide is having the positive slope. So must remember, for phase diagram of carbon dioxide, this is a typical phase diagram of a substance where the melting curve is having the positive slope. Okay, so why? So first we must see. So assume this is pressure P1 and this is temperature T1. When pressure increase to P2, so the green line is P2, can you see that the melting point increase to T2? Okay, so this is the normal behavior of a substance. When the pressure increase, the melting point increase. Okay, so why? Okay, so first we shall look at the melting process. Okay, so I'm using the carbon dioxide as the example. So carbon dioxide melting. So melting refers to the process where solid carbon dioxide is converted to liquid carbon dioxide. So this is a melting process. So when pressure increases, we can see from the graph, the melting point increases. The melting point increases. So means that when pressure increases, it is getting harder to melt solid carbon dioxide. So if getting harder to melt solid carbon dioxide means that we need to put in more heat in order to melt the solid carbon dioxide. So why? So we shall look at the particle arrangement in solid and the liquid carbon dioxide. So for solid carbon dioxide, we know that the particles in solid state, they are more closely packed. So when in the solid state, the carbon dioxide is more closely packed, means that the volume of solid carbon dioxide will be smaller because the particle carbon dioxide are more closely packed in the solid state. So we know that density is equal to mass over volume. So when the volume of solid carbon dioxide is lower, means that the density of solid carbon dioxide will be larger. While for liquid carbon dioxide, so in liquid state, so the liquid particles, they are separated further apart compared to solid state. So when they are separated further apart, means that they are occupying larger volume. Okay, so when occupying larger volume in liquid state, means that the density of liquid carbon dioxide is lower, Okay, so now we can move on to look at what happens when pressure increases. So when pressure increases, means that the particles are being compressed. So when pressure increases, the particles are being compressed. So when particles, the carbon dioxide particles are being compressed, means that now the particles need to occupy smaller volume. They were occupying smaller volume when pressure increases. So now look at solid carbon dioxide and liquid carbon dioxide. Which one has smaller volume? We can see that is the solid carbon dioxide having smaller volume. So means that as the pressure increases, the system will favor smaller volume and therefore it will favor formations of solid carbon dioxide because solid carbon dioxide has smaller volume. Okay, so now remember we are studying we are studying the melting curve, melting process. In melting process, we want to convert solid carbon dioxide to liquid carbon dioxide. But when pressure increases, it favors formations of solid carbon dioxide. Melting, you want to change solid to liquid. But pressure increase, one favors solid state. So in another word, it is getting harder for you to melt the solid carbon dioxide as the pressure increases. Okay, so as the pressure increases, it favors formations of solid carbon dioxide. So means that harder for you to melt solid carbon dioxide to liquid carbon dioxide. As it is harder to melt the solid carbon dioxide, therefore more heat you need to put in order to melt the solid carbon dioxide. Or in another word, we can say that as the pressure increases, the melting point of solid carbon dioxide increases. Okay, so this phase diagram is actually a typical phase diagram of a substance. So means that usually for a substance, when the pressure increases, the melting point will increase, just like the carbon dioxide. Now we move on to look at water. We look at water. What happened to the water when we try to melt the ice? So when pressure increases, so this is P1, so this is T1. So when pressure increases to P2, so can you see that the melting point decrease? The melting point decrease. Why? Okay, again, first we need to look at what is melting process. So melting process refer to the process where we convert the solid ice to liquid water. Okay, so solid ice to liquid water. From the phase diagram, we can see that as the pressure increases, the melting point decreases. Melting point decreases. So what does this mean? So basically, it means that as the pressure increases, it is getting easier for us to melt the ice. Okay, therefore, less heat needed to melt the solid ice as the pressure increases causes the melting point to decrease. So why? So again, we need to look at the solid ice and also the liquid water. So what happened in the ice system and also in the liquid water system? So in the ice, we know that for ice, each of the water particle, water molecule in the ice want to form maximum number of hydrogen bonds with other water molecule. So each water molecule want to form maximum number of hydrogen bonds with other water molecules. So means that each water molecule in the ice would like to form 4 hydrogen bonds with 4 other water molecules. So due to this, it causes ice to have a lot of hexagonal empty spaces. Okay, so due to these empty spaces in the ice, therefore the volume of the ice is big. Okay, and the density of ice therefore is lower compared to the liquid water. Okay, however, in the liquid water, so each of these water molecule not necessary to form maximum number of hydrogen bond. They are happy to form less than 4 hydrogen bond. Okay, like for example, this water molecule is happy to just form 1, 2, 3 hydrogen bond with other water molecules. And for this water molecule, it is happy to form just 2 hydrogen bond with other water molecule. So in liquid water, Because the liquid particles, the liquid water, liquid molecule, they are happy to form less hydrogen bond between water molecules, so they can be closely packed to one another compared to in the ice. Okay, so when they can pack themselves more closely with one another in the liquid state, therefore the liquid water will have lower volume compared to ice. Okay, so and the density of liquid water therefore is higher than the ice. Okay, when pressure increase, again, pressure increase, so the particles are being compressed. The liquid molecules are being compressed to occupy smaller volume. Okay, so now can you see that which one has smaller volume? Is the liquid water having smaller volume. So in other words, as the pressure increase, it will favor formations of liquid water because liquid water have smaller volume. Okay, in the melting process, we want to form liquid water. We want to form liquid water. As the pressure increase, it also causes liquid water to be formed more easily. Okay, also favor formations of liquid water. So both are going same direction. So because of that, less heat actually is required to melt the solid ice and causes the melting point to decrease as the pressure increases. Okay, and this causes water to have the negative slope for the melting curve. Any questions so far, moderator? No question. Okay, so no questions. Then I proceed with a phase change with respect to temperature. Okay, so
Teacher Tang, I think there is one question, but already answered. One student asked whether chemistry is taught in English.
oh yeah, chemistry is taught in English.
Then she said, can use bahasa Melayu sebab tak berapa faham.
Okay, so
I think they have to learn two languages, right? English and BM, right?
Yeah, but for matriculations, English, matriculations chemistry, students learn the chemistry in English. I think STPM as well. It's okay. Maybe I can use BM to explain some of the concept. Okay, so now we move on to look at how to explain phase change with respect to temperature when the pressure is remain constant. Okay, so in order to explain phase change with respect to temperature when the pressure is made constant, so there are a few steps you need to follow through. So first is to plot the initial conditions given first. Second, you can draw a vertical line or horizontal line to represent constant pressure. So yang ini, okay, and then step number 3, you need to label the points along the line that you draw in step number 2. So in step number 4, then you need to state the phase for each point that you label in step number 3. So untuk ini, kalau mahu terangkan phase change with respect to temperature and diberi pressure constant, so 4 langkah you boleh buat untuk menjawab soalan begini. Okay, so step number 1, you kena plot dulu mana initial conditions yang diberi. Biasanya initial condition diberi dalam soalan. Okay, so you boleh plot dulu mana initial conditions kamu. Lepas tu, you boleh lukis garis horizontal atau vertical untuk melambangkan constant pressure. Okay, and in step number 3, then on the garis yang kamu lukis in step number 2, you boleh label the point. Okay, so you label the point, and then step number 4, you nyatakan pada setiap point yang you label dalam step number 3, you nyatakan what is the phase. So, example, if the question asks you to explain how to form solid carbon dioxide at room condition, okay, so how to form solid carbon dioxide at room condition? So, how do you answer this question? So, again, step number 1, you need to plot the initial condition. So, here the initial conditions given is room condition. Okay, so room condition. So what is room condition? So yang ni kena ingat, room condition is referring to 1 atm 25 degrees Celsius. 1 atm 25 degrees Celsius. So you have the phase diagram for carbon dioxide. So step number 1, you need to plot this condition into the phase diagram. So where is this condition? So 1 atm is below the triple point. So you can assume to be here, 1 atm. And then 25 degrees Celsius, so it's here. So this is the point. Okay, so this is how you do step number 1. You plot the initial conditions given. Like in this question, they give you room condition. So you plot the room conditions into the phase diagram. Then step number 2, you draw a vertical line or horizontal line, okay, in order for you to explain how to form the solid carbon dioxide. Like for example, your initial condition is this point. The question say want to form solid carbon dioxide. So solid carbon dioxide is here. This is solid carbon dioxide. So how do you draw the line? So basically, you know it's here. So how do you draw the line? You just need to draw a vertical line. So join your initial conditions with the state. So this is solid. So you are drawing the horizontal line from your initial point in step number 1 to the solid state, given in the question. Okay, so this is step number 2. You draw the line. Okay, so for this question, okay, so this is the horizontal line that you can draw. Okay, and this horizontal line basically is representing constant pressure. Can you see that when you draw this line from point X to solid state here, so the pressure is constant at 1 atm. But can you see that the temperature you need to reduce from 25 degree reduce to this temperature? Okay, so basically this line that you draw is representing constant pressure but decrease in temperature. Okay, so this line that you are drawing basically is representing constant pressure but reduce the temperature. And then in step number 3, you need to label the points along the line. Okay, so what points you need to label? So you need to label your initial condition. So I label it as X. And then also, I need to label this point. Why I need to label this point? Because this point, Y here, having different phase with my initial conditions X. And then, I also need to label this point Z because it has different phase with X and Y. Okay, so basically, 3 points I need to label here. I label them as X, Y, and Z. And in step number 4, for each point that I label, I need to state the phase. So in X, it is in the gas region. so it's the gaseous state. And in the at the point Y, it is the solid and gas at equilibrium, and Z is the solid phase. Okay, so basically these are the 4 steps you can go through in order to get all the answer. If this is essay question, how can you write all these points into essay, into a paragraph? So basically this is how you write it.
Teacher Tang, I think we need to have
Yeah.
an advertisement. Okay, so
Oh, okay.
students, please, we'll come back in 2 shakes. All right, so just wait for a moment.
Alah, apa ni? PKPB lagi. SPM pula ditangguhkan. Jenuhlah nak bayar yuran tuition. Pernah dengar tentang tuition percuma? Kami di Akademi YouTuber menyediakan tuition online secara percuma kepada anda semua. Ada prasekolah, sekolah rendah, sekolah menengah, STPM, juga untuk matrikulasi. Percuma je. Jom layari laman sesawang www.academyyoutuber.com.
Okay, hi students, we are back now. Okay, Teacher Tang, you may continue. Oh, yeah, before that, we have a question from Nurul Aina Safia.
Okay.
Yes.
So what's the
She
question?
asked for H2O phase diagram. All right, we don't need to state what's that? Tetrahedral structure, open structure. That's a question.
Oh. In the
I'm not a
explanation.
chemistry teacher, so what is that term?
Okay, so basically, what you need to explain is you need to explain why the ice have a larger volume. So why the ice has larger volume? It is because in the ice, the water molecules, they want to form maximum 4 hydrogen bonds with 4 other water molecules. So because of that, causes the hexagonal open structure to be formed inside the ice, causes ice to have larger volume compared to liquid water. So you need to explain that the ice have larger volume compared to liquid water. Okay, so it's because of this larger volume compared to liquid water, that's why higher pressure, which favors smaller volume, will favor the formations of liquid water, because liquid water has smaller volume. Basically, that's it you need to explain. Okay, you need to explain larger volume in the ice compared to liquid water.
Okay, Teacher Tang, one more question from Jia Jun.
Yeah.
Okay, Jia Jun asked, PSPM essay question can write in point form?
That
Can they write
one.
in point form?
Okay, so you cannot write in point form. Okay, you cannot write in point form. So just now, the 4th step is to help you to get the answer. So I'm going to show you how you write your answer into the point form. So just now, the 4th step is to guide you how to write your essay question. Okay, so I'm going to continue on how you can write your answer in essay form. Okay, so with all the informations that you have just now, so you can answer your question. So how you answer it? First, you need to state the initial conditions, the room condition. Okay, so to form solid carbon dioxide at room condition, 1 atm 25 degrees Celsius. So remember, you draw the line, horizontal line, right? And the horizontal line represent constant pressure but decrease in temperature. You need to mention that in your essay. Okay, so to form solid carbon dioxide, so this is your initial condition, room condition, and then you need to explain, you need to reduce the temperature at constant pressure. That is the step number 2. You draw the line to represent the constant pressure but decrease in temperature. Okay, and then what will happen is the carbon dioxide then will change the phase from gas carbon dioxide at point X to gas and solid carbon dioxide at equilibrium at point Y to solid carbon dioxide in point Z. Okay, so this is how you construct your essay question. Okay, so then now we move on to the next example. So if the question asks how to form liquid carbon dioxide at room condition, so still follow through the 4 steps. First, you need to plot your initial condition. So the question given, room condition. So room condition is 1 atm, 25 degrees Celsius. So you plot that point first in your phase diagram. Okay, and in step number 2, you need to draw the line to form liquid carbon dioxide. So from the gas, your point X here, how can you get liquid carbon dioxide? Can you see that you need to draw a vertical line out, like this in order to get liquid region. Okay, so by drawing this
Sorry
line,
to interrupt, Teacher Tang. One more question
okay.
from a student, Nurul Aina Safia. Okay, she asked, this one, is it isobaric?
Oh, for this one,
I hope I
just
pronounced
now,
the term correctly.
the previous example, constant pressure is isobaric. So again, isobaric, iso means same, or you can say constant. Baric is pressure. So isobaric is constant pressure. So for this one, constant temperature is isothermal. So iso means same or constant. Thermal means temperature. So this example here is isothermal. Okay. So just now I have gone through step 1, and step 2 is drawing the vertical line out. Okay. And when draw this vertical line up, so basically it is referring to constant temperature, 25 degrees Celsius, but the pressure increases. Can you see from this 1 atm, you increase to this, to above, to the liquid region. Okay, so you increase the pressure. So that is step number 2. So in step number 3, you need to label the points along the line. So which points you need to label? So it's the point X, because this is the gaseous phase, and this point R, because this is liquid and gas at equilibrium, and S is the liquid phase. Okay, so 3 points you need to label along the line. And in step number 4, for each point you need to state, okay, the phase. Okay, point X, you have the gas. R, you have the gas and liquid at equilibrium, and S is the liquid phase. Okay, so after you have all the points, then you can write them in essay form. Okay, in paragraph. Exam answer in paragraph. Okay, so how do you explain this question? So again, first you need to write the initial condition to form, this is liquid carbon dioxide, okay, at room condition. So liquid carbon dioxide at room condition. So again, the temperature is constant. But you are drawing the vertical line out that represent increase in pressure. Okay, so to form liquid carbon dioxide at room condition, so you increase the pressure at constant temperature, and this causes carbon dioxide to change phase from gas carbon dioxide at point X to gas liquid carbon dioxide at equilibrium at point R to liquid carbon dioxide at point S. Okay, so this is how you answer your essay question. Okay, now we can move on to the question. So for the question, if the question asks you to describe the phase change when carbon dioxide is heated from negative 80 degrees Celsius to negative 20 degrees Celsius at constant pressure of 50 atm. Again, to answer this question, first we need to plot the initial condition. So any students want to answer my question? From this question, what is the initial condition? What is the initial conditions given in the question? Anybody? Any students? What is the initial conditions? It's given in the question. So you just need to read the question and then you can find your initial conditions. So any students give the initial condition?
Okay, students, come on, give your answer in the live chat. Be responsive. I hope you're participative, dear students. Yeah, okay, good. Julia said solid. What else?
Solid, initial condition. So what is the temperature and pressure? What is the temperature and pressure, class? You need the temperature and pressure in order for you to plot the initial condition.
Okay, minus 80 degrees Celsius.
Yes, so the temperature is correct already, and the pressure is 50 atm. So it's given in the question from negative 80 to negative 20 degrees Celsius at 50 atm. So that is your initial condition, negative 80 degrees Celsius, 50 atm. So where is it? Yes, it's in the solid state. So basically
Okay,
it's
good
about
job.
here.
I think X guy got the answer.
Okay, good. So, and that it is, somewhere here. So you can plot it. Okay. And then, step number 2, remember, you need to draw the line. So now at constant pressure, you want to increase the temperature to negative 20 degrees Celsius. So anybody want to tell me you need to draw horizontal line to the left, to the right? Vertical line, up or down? Which one? Horizontal to the left, horizontal to the right, or vertical up, or vertical down? Which line you need to draw? Anybody?
Okay, students, you have options to choose. just choose one.
So 4 options. Vertical line up, vertical line down, horizontal line to the left, horizontal line to the right. So which one represent increase the temperature from negative 80 degrees Celsius to negative 20?
I answered first, horizontal to right.
Okay, so shall we see? Okay, good. He got it correct. So you need to draw, you need to draw horizontal line to the right, okay, to represent the increase in temperature from negative 80 degrees Celsius to negative 20 degrees Celsius. Okay, so that is step number 2. And this basically represents constant pressure increase in temperature. Okay, and in step number 3, you need to label the points along the line. Okay, so you need to label the points where the phase are different. So in this question, so there are 3 points with different phases. Okay, so the first one is the V, and the second one is the W. So the W having the solid and liquid at equilibrium, and X having the liquid phase. Okay, so in step number 4, then you can state the phase. Okay, if the question asks you to describe the phase change, basically after you get all the four steps, you go through all the 4 steps, you need to answer in a paragraph. Okay, so but if the question asks you to state the phase, then you can just state the phase like this. Okay. So then now we move on to look at question number 2. Question number 2. So question number 2 asks, describe the phase change when water vapor initially at 0.001 atm and negative 0.005 degrees Celsius is slowly compressed at constant temperature until the final pressure is 20 atm. Okay, so for this question, can you see that constant temperature, but the pressure increased from 0.001 atm to 20 atm. Okay, so again, to answer this question, step number 1, you need to plot the initial condition. So from this question, class, can you tell me what is the initial conditions given? Any students? Initial conditions given.
Okay, they are still quiet.
Okay, class. What is the initial conditions given in the question?
I think Shafiq is asking a question, solid, and put a question mark.
Soalan kata water vapor initially. So Shafiq,
Okay,
water vapor.
Dania answered negative 0.005 degrees Celsius and 0.001 atm.
Okay, very good. That is that is the initial condition.
The first one to give answer.
Very good. Okay, and the questions also telling you that the initial condition is at the vapor phase. Okay, it's having the vapor phase, means that gaseous state. So where should be your initial conditions in the phase diagram? So it should be somewhere here. Okay, so it should be somewhere here. Okay, so 0.001 atm, negative 0.005 degrees Celsius, and it must be in the gaseous state because the question telling you that initially is water vapor in the gaseous state. Okay, so that is step number 1. You plot the initial condition, and then the question say the final pressure is 20 atm. So in step number 2, you need to draw the line to 20 atm. So how should you draw the line? You should draw it vertical up, vertical down, horizontal to the left, horizontal to the right. So which one you need to draw? Class? Anybody want to answer my question?
Okay,
draw
give them some time to answer.
Okay, vertical. Draw vertical line.
Vertically up.
Okay, good. Okay, it's vertically out. Okay, because the final pressure is 20 atm. So you need to draw from 0.001 atm up to 20 atm. Like this. Okay, and this line basically representing constant temperature. Temperature tak boleh ubah because soalan kata constant temperature. Okay, but the pressure increase. So to represent pressure increase, you need to draw vertically out the line. Okay, so 0.05 atm to 20 atm. Okay, so this is step number 2. And then in step number 3, you need to label the points along the line. And when you label the points right, measure those points represent different phases. Like for example, your initial point V, this is gas, and then W is solid and gas at equilibrium, and X is solid state. Okay, so if the question asks you to state the phase, so you can state like this. Okay, but if asking you to describe, then you need to write it in the essay form, like the example that I showed you before. Okay, so now come to the last question. Okay, question number 3. So for question number 3, you need to think first how to answer this question. Okay, because this question do not give you a very straightforward initial condition. So how do you answer this question? So the question asks, how to make ice water. So basically ice sublime. So how do you make ice sublime? Okay, so basically ice, okay, you want to make it sublime. So must remember, this is sublimation. So what does sublimations mean? Sublimations basically means that the solid, you change it to gas. Okay, so solid ice convert to water vapor gas without passing through liquid phase. Okay, so you must first understand this first. Okay, so sublime here refer to solid ice becomes the water vapor gas without passing through liquid phase. Okay, so now if you understand what is sublimation, then it will be easier for you to plot your initial condition. So which condition would represent sublimation? So must remember, sublimation means that solid become gas. So means that your initial condition must be solid. But where to plot? Should we plot here, or here? So A, B, or C? Which A, B, or C? Which one is our initial condition in order for us to explain sublimation? Class, A, B, or C? Which one is
3 options for you to choose?
which one is our initial condition for sublimation? Must remember, sublimation without passing through liquid phase. Solid change to gas without passing through liquid phase.
A, B,
So
C?
A, C.
Okay, most of them answered C.
Okay.
Jajun, Prishita,
Okay.
Bonia.
Okay, good. Very good. Okay, very good. The answer is C. Why? It's because if B, it will pass through liquid phase. A also will pass through liquid phase. Only C, the solid carbon dioxide, it can be converted to gas carbon dioxide. Water. Okay, sorry, this is water. So A and B both will pass through liquid water, but for C, the ice, it will sublimes to become gas water without passing through the liquid phase. So very good. The initial condition should be C. Okay, should be C. And this C, can you see that it is below triple point pressure? So you must mention that in your answer. Okay, in your answer. So you need to plot your initial condition. Okay, below triple point pressure. So why must be below triple point pressure? It is because if below triple point pressure, then the solid ice can sublime to become gas or water vapor without passing through liquid phase. If you are having any point above triple point pressure, then it will pass through liquid phase. Okay, so because of that, your initial condition must be the solid ice below triple point pressure in order not to pass through liquid phase. Then step number 2, you need to draw the line. Remember the question say you want the solid ice, so solid ice to become water vapor gas. So solid ice become gas. So means that you need to draw a horizontal line to the right. Okay, to the right in order for the solid ice to sublimes become water vapor. Okay, so and this line basically represent constant pressure but temperature increases. Okay, so and then step number 3, you need to label the points along the line. Okay, must remember each point that you label, it must represent different phases. So point X represents solid water, so the ice, and Y solid and gas at equilibrium, and the point Z you have the water vapor. Okay, so the gas. And if the question is essay question, this is how you answer it. Okay, so first you need to explain what is sublimations first. So sublimations of ice basically means that the solid ice is changing to become water vapor, the gas, without passing through liquid phase. Without passing through liquid phase. Okay, so means that it will be any point below the triple point pressure as your initial condition. Okay, and then how do you make the ice sublimes? Remember just now we draw the horizontal line to the right. Horizontal line to the right. So means that the temperature is increased at constant pressure. So this is the constant pressure. Okay, but the temperature increased from X to Z here. Okay, and then it must be below triple point pressure. Oh, okay. Below triple point pressure. Okay, and then the last things you need to mention is the phase change. Okay, so when for ice to sublime, okay, so you can increase the temperature at constant pressure below triple point pressure, and then the ice will change phase from solid ice at point X to solid and water vapor at equilibrium at point Y to water vapor at the point Z. Okay, so this is how you answer the essay question. So that's it from me for tonight. Thank you.
Wow, all right. Thank you, Teacher Tang, for a great lesson.
So,
all right, dear
any
students,
questions?
I think we have provided the link sigil for all of you. All right, don't forget to, click on that link to get your sigil. And remember, as a token of by showing your appreciation, we would like you to, give Teacher Tang support. Can you please smash the subscribe button? All right, and I hope that you have learned a lot from Teacher Tang. Okay, and I hope that all the visuals will definitely guide you. Okay, make sure you subscribe Teacher Tang's channel. Just click subscribe button. Make sure that it has turned gray. Okay, and thank you for staying with us until the end of the lesson. We hope that you have learned a lot from Teacher Tang, and just show your appreciation by supporting all of us. All right, smash the subscribe button. Thank you for your support, and we will meet you again same time, okay, same day. All right, don't forget to join IU Tuition. For further information, you can always go to www.academyyoutuber.com. All right, because there you can find daily classes. All right, all the schedules for daily classes. Thank you for joining us, and I think we have to say goodbye now. Okay, bye-bye. Have a good night.
Tuition online percuma. Tuition online percuma. Layari www.academyyoutuber bagi mengikuti tuition online secara percuma. Prasekolah, sekolah rendah, sekolah menengah, semua ada di Akademi YouTuber. Rujuk jadual di laman sesawang www.academyyoutuber.com. Semoga masa terluang anak-anak anda diisi dengan sebaiknya. Tuisyen online percuma mestilah Akademi YouTuber.
Dibawakan kepada anda oleh Akademi YouTuber.